This is page 11. We are looking at angles. We're going to look at the geometric definition. We're going to look at how to name them. And then we're going to get into how to measure them. If you look at the top, this is kind of just an exploration. We're going to guess, without actually measuring, which angles we think look the same. This vocab word right here, congruent, you should have heard this before, but congruent is the geometric word for equal. So when I say which angles are congruent, I mean which ones look like they measure the same, like they look like copies of each other. For us to answer this question, it would be a lot easier if we could talk about the angles by names instead of top right, bottom left. So what we're going to do is we're going to put a point on the vertex of each angle, putting a point. The fancy math word for that is called the vertex. Sometimes I call it the elbow of the angle, and I'll make this demonstration where I show you my arm and I point to my elbow, because I want you to remember that when your arm is stretched out or folded, it forms an angle. These are angles. Now we're going to put capital letters next to each one of those points. This would be A. We're going to go alphabetical. And this is one of the ways that you can name an angle, is by just the vertex of the angle, or the elbow. So if I say angle B, everyone's eyes would be looking at the angle over here with point B at the vertex. Okay, take a second. We're not going to say there's any wrong answers here, because some of these are really close, like I think you could argue either way. Take a second and try to match the angles that are congruent. So like angle A has a copy in here. Find it, and I want you to come over here and I want you to tell me what angle A matches. So you would write angle A, and then here's the congruent symbol. It's like this, equal sign. And then it has what's called a tilde above it. Have you ever seen that before? Have you seen it in Algebra 1? Yes? Then you would tell me what angle it looks like it's congruent to. So this has no numbers involved. This is just looking and comparing. Take a second. You have 8 angles total, so you should end up writing 4 lines here. Take a second, go through. Some of them are kind of easy, and then I came down to 2 pairs that are kind of like, okay, I'm not really sure, but we're going to go with this. All right, what angle did you say A looked like it matched? And we might have different opinions here, and that's okay. I know for a fact nobody said A matched G, right? If you look at A and G, they definitely look totally different. But what angle did you say A looked like it was congruent to? F? Okay. So that's so funny. I said D. But we'll go with it. All right, angle F. If you are trying to talk about two angles that are congruent on a picture, what you do is you draw an arc. So this arc right here, and then you go to the other angle and you draw the same arc, and that says, hey, these are equal. That's the notation for congruent angles. All right, let's just go in alphabetical order right here. What did you say B was congruent to? I said G as well. Now, if I come over here to show congruent marks on B and G, if I draw 1, is that clear or confusing with my picture now? With 1, if I draw the 1 arc, have I distinguished it from A and F? No, now it looks like it's congruent to all 3, right? So what you do is you draw a second arc. All right, what about C? What did you say C looks like it was equal to? What? I said E as well. All right, so we already know we can't do 1, can't do 2. Sometimes you'll see 3, so I'm going to go ahead and do 3. The trick to drawing 3 is just make them really small, and that way you don't get ridiculous with it. And then that leaves us with D. Looks like it's congruent to, let's see, H. Okay, now we definitely don't want to go in there and draw 4 arcs. That's ridiculous. So let me show you another approach for drawing congruent angles without having to draw 4 arcs. You can draw the 1, and then you put, I call it a tick mark, a dash on it. So 1 and then a dash. So that's another approach to showing angles are congruent. Okay. When angles are congruent, by the way, it means that they measure the exact same. Now let's get to the definition. We just played around with an angle. Highlight the vocab word angle. Can you tell me what geometric shape that we learned yesterday looks like is part of an angle? There's 2 of them put together. What? Rays. Very good. All right, here's the formal definition. It's an angle is formed by 2 rays sharing the same endpoint, which is called the, here's where I need you to take your highlighter. Whenever I need to highlight a word, I tend to highlight the paper first and then I write over it because then the highlighter doesn't bleed the pencil. So take your highlighter and draw a highlighted space right here for us to write the word vertex, because that is another vocab word. That's another vocab word that you need to know. And if you will take your highlighter and highlight point A right here, so that now the vertex of that angle is highlighted along with the vocab word vertex, so it should stand out as, okay, that's the vertex. When 2 rays come together, they form an angle. The vertex or the elbow of the angle is the one in the middle. There are several ways to name an angle. You can name it, it says right here, how do you name it? By the vertex That's one way, which is what we did at the top of the paper. I'm going to write in all capital letters to say, or 3 points on, and then I'm running out of room, so I'm leaving the word B out. 3 points on the angle. And I abbreviated the word angle with a mini angle symbol because I ran out of room. So you can name it by the vertex, or you can name it by 3 points on the vertex. So for instance, this right here is an angle, and we're gonna actually show like 4 ways to name it. The first way we could name it is by A. We could call it angle A. So if I said angle A, you would direct your attention to that angle. Or, I'm going to put comma. Another way to name it is by the 3 points on it. Now here's where order matters. You have to be careful. Okay? You name it by 3 points so that if you were to trace those letters in the order that you named it, you would end up tracing the angle. So we'll say that again. 3 points in order that traces the angle. Here's what I mean by that. If I wanted to call this B, A, C, that would be allowed. If I wanted to call it C, A, B, that would be allowed. Red means wrong. If I tried to call it A, C, B, I have totally gone off course. You see the difference? ACB does not exist. BAC exists. CAB exists. So there's only 2 ways to name it by 3 letters. BAC or CAB. Which one do you notice is in the middle? A, and that was the vertex. The elbow. Think of your arm. What's in the middle of your arm? Your elbow. It's the hinge, right? So I want you to underline the A a couple of times just to draw attention to the fact that that middle letter absolutely has to be the vertex every time. Now you might be wondering, why is there a random 1 floating on the inside? When we get to complicated pictures where naming it by 3 letters is a headache because there's more than 1 angle in the picture, we can assign numbers randomly to the floating quarter of the angle, and we can actually name it by a number. This does not mean that it measures 1 degree. This is saying, hey, this is angle 1. Like from here to here is angle 1. So I'm going to put or angle 1. In this particular picture, you can name it angle 1 as well. All right, so that's a lot to take in. But that right there, that's all there is. There's no other tricks. Like, that's it every time. And that is very important to understand for the rest of the semester, okay? For the rest of the semester, that's really important to understand because what we're going to cover down the road is going to be new stuff, and then this should not be what trips you up, you know what I mean? Like, you need this to be not a problem, because then I'm going to throw the new stuff at you. All right, does anyone remember what this antiquated thing is? Right here? Yeah, it's a protractor. We don't really use protractors anymore because now there's digital technology that we can measure stuff. But good old-fashioned protractor used to be how you measured angles. Now, construction crew, they may still use it, I don't know, or unless they have some fancy tool that works better. The way a protractor worked, we're not going to spend a lot of time here. The way a protractor worked was you lined the bottom of the angle, like you picked one ray of the angle to be the bottom, and you lined it up right here, the vertex. and then you looked at where the other ray hit on the measurements of the protractor. And you might, if you look at yours, which is kind of hard to read the numbers, you might be wondering, well, why are there two rows of numbers? And one row's small, the other row's big. Well, whoever came up with the protractor decided, you know what, people should be able to measure the angle regardless of how they laid the protractor down. They shouldn't have to turn it the right way. They should just line up the vertex and one ray, and then they should be able to measure the angle. So what they did was they created two rows of possibilities. And you just have to know that if I'm looking at, like, for instance, this one, see this purple angle? Clearly, from here to here would measure small numbers, not the 165 that you see. So you go with the small numbers if it's a small angle. You would go with the big numbers if it's a big angle. Let's practice naming these angles that are over here. Number one, you have two angles. I want you to name them three different ways. Name them three different ways. It has to do with the letters. There's no floating number. So, name those angles three different ways. Look at our example in the previous box. We talked about naming it with three letters. Okay, stay with me. Alright, what's one name for the first angle? Angle D. Yeah, you definitely could call it angle D because that is the vertex. Can I call it angle E? No. You have to. If you're going to use a single letter, it has to be the elbow, the vertex. Alright, what's another way to name it? Yep, you could trace E, D, F, and that would trace it. And then, what's the last way to name it? Thank you. FDE. Just goes in reverse. Reverse, reverse. Right? Alright. What about the next angle? You can call it angle L. Or KLM, or reverse, MLK. When you name the angle, trace it visually, like with your eyes. I'm not saying you have to take your actual pencil and trace it every time, but just trace it with your eyes to make sure that the letters you just chose, the order actually traces the angle. All right, come down to the bottom. We're not going to worry about the protractor, because like I said, that's an antiquated thing. We don't actually do that. Please take your highlighter and highlight congruent angles and angle bisector. You're highlighting congruent angles and angle bisector. Okay, we already talked about what congruent angles are at the top of the paper. We said they are angles that are what? Equal, the same. Angles with the same measure or equal. Look at the picture to the right. you will notice we have two angles. We don't actually know what they measure, but we're going to pretend like I said, hey, these angles are congruent. Okay, if I tell you two angles are congruent, you need to go to the picture and you would take notes. Here's what I mean. You're going to hear me say this a lot, so watch. If I say take notes on the picture, what I mean is make marks to indicate what you know about it. If I say these angles are congruent, then I'm going to draw congruent marks, so now my mind doesn't have to think, are these equal or not? I know they are. I just made marks. All right, there's two ways to write that those angles are congruent. One way would be naming one of them what? Angle. What's up? Angle. Name it with one letter. Very good. And then name the other one. There it is. And then I'm going to write or. Now name it with three letters. Be careful. Trace it correctly. You mean one of them. Name this one. Bam. Now name the other one. Perfect. By the way, if you name this one D, E, F, it's okay if you name this one K, J, I. That doesn't matter. What matters is just that you traced in the same, or that you traced the angle correctly. Definitely have my candle. I'll sit right there. All right. What is an angle bisector? What does bisect sound like? You know what dissect means, like in science, but bisect. What prefix bi? Bi implies two, like bicycle, two wheels. Bisect means it's intersecting it into two equal parts. Okay? So, an angle bisector. Here we go. That would be a ray that divides or cuts, whichever word you like, divides or cuts, an angle into two congruent parts. Look how I wrote the word congruent. There's no need to write the whole word out. Let's practice writing the congruent symbol. A ray that divides an angle into two congruent parts. So in this picture, there's a lot going on right here. We're going to take our highlighter and we're going to highlight the actual angle bisector. That would be this ray in the middle that's cutting the big angle in half. The short definition for bisect is cuts in half. Okay? What does bisect mean? Cuts in half. What's bisect mean, Houston? Cuts in half. Okay, let's stay with me. What's bisect mean? Anybody? You just heard that answer twice. What's bisect mean? Cuts in half. Guys, if you'll say it out loud, you'll be surprised that later down the road when I say, hey, what's bisect? Your mind is naturally going to say cuts in half because I just programmed you to do that. What does bisect mean? Cuts in half. Everybody that's answering is going to get it right. All right. Ray LO is cutting in half that really big angle. Okay? Let's take notes right here. LO, and it's a ray. Yesterday, when you did your Delta Math assignment, did you learn by experience, trial and error, red means wrong, don't write this, that you never draw a ray symbol that way? Did you learn that? I wanted you to come across that on your own. I didn't want to tell you. A lot of times learning by experience is more effective than me telling you, hey, you don't ever draw it this way. But you should have learned in the Delta Math assignment yesterday, if you selected the ray pointing left, then it told you it was the wrong answer. You'll never see the ray pointing that way. It's always going to go to the right. All right, so ray LO bisects. And then now let's name the large outer angle. What is the large outer angle? MLP. Can I call it just angle L? This is a trick question. Somebody say no. Somebody say no. No. You cannot call it angle L. Here's why. I'm going to use highlighters to help you. Don't write this down. If I say angle L, because there's a third ray coming from L, I could be talking about this, MLO. I could be talking about this, OLP, or I could be talking about this, MLP. Do you see how there's actually three angles there? You got the two piece angles, but then you have the outer angle. So you need to know that anytime you're trying to name an angle by just the one letter, by the vertex, make sure there's only two rays coming from it. If there's more than two rays coming from the vertex, you can't name it by a single letter. You have to name it by three, and you have to trace it. All right, so it is bisecting angle MLP. If I tell you, hey, this angle's being bisected, what's bisect mean? Cut in half. Very good. I've just secretly told you value about the picture. Now, I've not told you what they measured, but I did tell you that they're cut in half, which means you have two equal parts, right? So if I say, hey, this angle has been bisected, you need to take notes on the picture. What does that mean? You need to come over here and say, okay, so that's cutting this whole thing in half, which means I have two equal parts, which means this must be equal to this. And that would be taking notes on the picture, which is going to help you when we get to our practice problems, okay? All right, at this point, I'm going to set a timer. I'm going to give you a 2-minute brain break. You can check your phone, take your AirPods out. And then after you finish, your 2-minute brain break, you will need a calculator for the next section, okay? Okay, if you go to the back of this paper, this is where we're putting it all together. And then we do have one new thing in the middle of the paper that we'll highlight, and then we'll be done with the highlighter. It starts simple, kind of like the shallow end of the problems, and then it moves into more grade level appropriate, okay? Look at number 3. It says, find the measure of each angle. Well, number 3 asks for it. Let me explain this notation. M angle QRS. This means the measure of angle QRS is what? Which means they want you to either tell me how much it measures or what expression of X does it equal. Well, looking at the picture, find QRS, put a question mark where you're trying to answer, like what's the goal? The goal is the measure of angle QRS. Train yourself to put a question mark on the goal, because this is very easy, but we're going to get to complicated, and if you will do these little easy steps, it'll make the complicated questions a lot easier. This should be simple because it's marked with, what's this mean? This is a what mark? Starts with a C. Congruent mark. And then it's right over here repeated, which means these angles are what? They're the same. So what is the measure of QRS equal? Yeah, it tells you right there. It's 32 degrees. Now look at the next one. Ray BC bisects angle ABD. Find the measure of angle ABD. Let's take notes on the picture. They've just told me that something is bisected. What does bisect mean? Cuts in half, which means you have two equal parts. Mark the two equal parts. If ray BC, right through the middle, is bisecting angle ABD, then my two equal parts are right here, right? Now, you could draw your mark like that, or what I tend to do, that kind of sometimes throws me off. Sometimes I look at that and I don't know why. I see one angle instead of the how many are actually there. So sometimes I stagger mine. So it helps me remember, okay, I got the two pieces, but then I also have the really big one. So what is this? This is what? This measures, this measures 27 degrees, so what does this have to equal? 27 degrees. And it asked for the entire angle, right? It says, tell me the measure of A to B to D. Well, ABD is from here to here. So what does that have to equal then? Huh? 54. You just add the parts together, right? Part plus part equals whole, which is actually what this is down here that we're about to come to. So it'd be 54 degrees. All right, number 5. This time they're telling you angle XYZ is 128. They're asking for angle XYV. Let's take notes on the picture. Guys, I promise if you'll take notes on the picture, the problems are easier. I've had kids tell me straight up, I don't know what I'm doing, and then I look at their paper and it's blank. And I'm like, well, if you'll take notes on your picture, it'll actually guide you through the process. Okay, so what would notes look like here? I'm going to label what I know. X, Y, Z. So X, Y, Z. That is the entire angle, right? And I know that it measures what? 128. So I'm going to come out here and write, okay, that whole thing's 128. Then I'm going to put a question mark on the one they asked for. They asked for X, Y, V. Trace it. X, Y, V would be this one. How am I going to find it? Yeah, they gave me the total. There's something marked in the picture to tell me the relationship between these two angles. This right here tells me that it's congruent to this over here, which means this is two equal parts. So I'm just going to do 128 divided by 2. And what do you get? 64. All right. Those 3 problems are when you're dealing with just numbers. We are going to be dealing with algebraic expressions. Algebraic expressions means you don't actually know the true value of it, but you do know the expression of the value. That's where all these expressions of x come in. This is a lot. When you first read this, you're probably like, lost in when you read it. Label your picture with what they've given you, and then it'll be easier. They're saying the measure of angle FGH is 21x minus 6. FG, careful, H. So that's actually from here to here, right? So find the slice of pizza, like this would be this expression right here. So 21x minus 6 degrees. Then it says HGI is 15x. HGI I is 15x degrees. It says, what's the measure of FGH? So the goal is the actual degree measure of this angle right here. This is a lot of what's going to happen in this semester, and you're going to hear me say the same thing every time. First, take notes on your picture. Second, look at the relationship. There's some type of relationship to allow you to set up an equation and solve it. Usually, it's two things are equal, or two things add together to equal something else. In this picture, what's the relationship? There's something we've not talked about yet. There's congruent marks. Do you see the congruent marks? This congruent mark here and then here is letting you know that those two angles are equal. While I don't know what they actually measure, I do know that this crap has to equal this crap. There's your equation. So set it up. This crap equals this crap. 21x minus 6 has to equal 15x. And now you just set up a two-step equation that you would solve for x. Which now you can see why we practiced that last week and the week before. So solve that equation for x. You do have an x on both sides already, so you do need to consolidate that, right? You need to consolidate that. If it bothers you to have x on the right, it's no big deal if you move it to the left and then move that 6 to the right. Did you get 1? X is 1. Now, if I tell you the answer, you shouldn't just write it down and run with it. Like, you should do the work to get to the 1. I'm going to subtract 21x. It's positive. I'm going to come over here and subtract it. So I bring down my negative 6. 15 minus 21 would be negative 6 as well. Then I'm going to divide by negative 6 on both sides. Now, did it say solve for x? No, it said tell me the measure of the angle. What do you think I do with x? Plug it in. Plug it into the right one, right? In this case, well, I say plug it into the right one. What do we know about these angles? What do we say? They're equal. So if you just want to do it in your head, you could plug it into the 15x and you would have the correct answer, right? But technically it would go in the 21x minus 6. What do you get for the measure of angle FGH? 15 degrees. All right, everybody try number 7. It says, what's the measure of angle XYZ? So this is the goal. Look at the picture. It's already laid out and labeled. There's really no notes to take on the picture. You can go straight to setting up an equation. What equation did you do? Like, what did you do with them? Did you add them up to equal something? Or did you set them equal to each other? Anybody? Yeah, set them equal. How do I know I can do that? What in the picture tells me, hey, these are equal? This mark is telling you those are equal. So set them equal. 7x minus 5 equals 3x plus 7. Doesn't matter which one's on which side. The only reason I put 7x minus 5 on the left was because it had a bigger number in front of the x. So this is a multi-step equation. We practice this. We need to consolidate our variables, then our numbers. So I'm going to take this positive 3x over here. I'll show my work a little bit in case you need to see the work. Now I have x on the left. I'm going to move minus 5 to the right by addition. You show your work. It is easier in the thought process. Then I'm going to divide by 4. Now I didn't say find x. It said tell me the measure of x, y, z. So what do I do now? Plug it back in. Right here where there's x, I'm going to plug in 3. So 7 times 3 minus 5. And what do you get? 16 degrees. All right. What you've just done is called the angle addition postulate. You did this without even realizing it. So basically, let's highlight this. Don't let the word postulate confuse you. Postulate is a fancy math word that means the following is a statement that can be used in geometry. Postulate. It's like a rule. Okay? Focus on angle addition. They name stuff to help you know what it's doing. You're taking angles, you're adding them together. This picture over here has 3 angles. You have your 2 part angles, and then you have your outer angle. The angle addition postulate, you're going to hear me say this a lot, is part plus part equals whole. Part plus part equals whole. So, you can name this by 3 letters. You could say angle ABD plus angle DBC equals angle ABC. But that's a lot of letters. So let's assign some numbers. And I hate to do 1, 2, 3, but I guess I will. Let's call this angle 1. Let's call this angle 2. And we're not going to call the outer angle 3 because that would look weird. We're going to call the outer angle by the 3 letters that it is formed by. All right, so here we go. Ready? Angle 1. If I add that to angle 2, then I would get the measurement of the outer angle ABC. So, same exact thing we've been doing, but now instead of just 2 angles are equal to each other, now the angles are not equal, but if you add them up, you get the outer angle. So there's your equation. Part plus part equals whole. Look at this one. It says find the measure of DEF. Trace it. DEF. That is the outer angle. You're going to hear this phrase a lot. Go to what you know. Go to what you know in the picture. Ms. Holcombe, I don't know what to do. Go to what you know. What do you know in the picture? I see a what and a what. What do you see in the picture? What values? Number 8. I see a 22 degree. What else do you see? 48. And we just learned part plus part equals whole. So the 22 plus the 48 would give me the whole thing. And what do you get? 70. 22 plus 48, which is 70. All right, look at number 9. We have angle TUW is 158. Find angle VUW. Then we have a 67 in the picture. Take notes on your picture. Label what's 158. Label a question mark on the goal. Take notes on your picture. Did you put an arc here to say the whole thing's 158 and a question mark here? This is still part plus part equals whole, but the difference here is we're not trying to find the whole. We actually know the entire thing, right? We're trying to find one of the parts. So there's 2 ways to do this. One way is to set it up part plus part equals whole, and then solve for the question mark. That works. So I'm actually, let's see, I'm going to show you both ways on, I'm going to draw a line and write both ways. So part plus part equals whole, right? And then what would I do to solve that? Subtract. You would get that the question mark is 91, right? That's one way to do it. Works every time. Part plus part equals whole. Fill in what you know, and then solve. Or, if you already know what's going on here, I know the total, and I know one part, I need the other part, you could just go ahead and go straight to subtraction. You could take the whole and subtract off the part you know, and that's going to leave you with what you need, which is the other part. So 158 minus the 67, and you still get the answer 91. So either way works there, okay? It all depends on how your mind sees it. Now let's get into some more challenging ones, and that would be the last 3. This does get a little crowded on these 2, so don't write big. Okay, we have a blank picture on number 10. Take a second, read it, and then take notes on your picture. Take notes on your picture. Label your picture with what they give us. Did you put, so DGE, did you put 6x minus 5 here? EGF, 12x plus 11 here? And did you make a note, so from here to the whole thing, did you make a note that the whole thing's 33? All right, and the question says, what's x? So we're solving for x. Well, there's no way we can solve it by just looking at the picture. You're going to have to set up an equation and solve it. The equation is either going to be 2 things are equal, or part plus part equals whole. What are we going to use here? Yep, I've got my 2 parts, and I know the entire thing is 33, so we're going to do part plus part equals whole here. So one part is 6x minus 5 plus the other part's 12x plus 11. The whole is 33. And again, now you can see why we practice solving multi-step equations like this. Because now it is just like last week. Solve that. You should get 1.5 here, or 3 over 2, but 1.5 is what you should get at the end. If anybody needs me to work it out, then just kind of give me that look and I will. Or call me over there and I'll help you. But you should come to 1.5. Good to move on? Okay, number 11. This time the picture has some labels already in it, but not everything's there. Let's label the 75. So take notes on your picture, put the 75 where it should be. Did you put it here? To show it's the whole thing. And then the question says, what is the measure of angle TRS? Did you put your question mark here? So before I can even find the measure of angle TRS, I need to know what X is. So again, I've got to set up an equation. Well, we've only learned 2 techniques. Either 2 things are equal, or part plus part equals whole. What do you think we do here? Yep, part plus part equals whole. Make sure you pick the correct parts. The whole should be the entire amount that stretches from one angle to the other. So we got 6x minus 2 plus 4x plus 7 has to equal 75. You're going to solve that, and then when you get x, you're not quite done. You're going to have to take x and do what with it? You're going to have to plug it back in. You should get x is 7 here. If anybody needs me to work it, I will, or if you want me to come over to your desk and help. If you can't get to 7, no big deal. What do I do with the x? It's 7. No. Did it say solve for x? No, I have to do what with it? Plug it in. And this is... I'm not even touching the screen. Here it goes. This is where... Let's hurry. This is where it's helpful to have that question mark because after you go through all this, you don't want to forget what was the whole purpose of the problem. So that question mark tells me I'm plugging 7. I'm plugging 7 into 4x plus 7, right? So that'd be 28 plus 7 is 35. Okay. The last one. Do you notice that it got more challenging because they didn't give you a picture at all, right? What picture do you think it is? The same one we've been working with. So you're going to draw just a generic big angle with a ray shooting out kind of in the middle, and then you would label the big angle. You have to be careful here. You have to look at it. Is it going to let me write it? No. I'll draw it on the marker board over here so that you can see it. Hold on, let me stop that before. Word. No.